Have you ever stopped to think about the invisible system that powers literally everything in your life? From the screen you're looking at right now to the coffee in your mug, it's all connected to this huge, hidden economic web. Today, we're going to pull back that curtain and dive into the fascinating world of energy economics. So, to get us started, here's a little puzzle for you. Let's say you want to drive your car about 10 kilometers. How much crude oil, the raw stuff right out of the ground, does it take to make that happen? Now, you might be thinking, well, probably about a liter, right? A liter of gas in the car, a liter of oil out of the ground. But the real number? Well, it's staggering. Stick with me, and we're going to figure this out together.
So here's our game plan. First, we'll get a handle on what energy economics even is. Then we'll look at all the different ways experts classify energy, because that's super important. We'll take a quick trip through history to see how our biggest worries about energy have changed over time, and then we'll trace the whole supply chain, from the source all the way to the socket. And all of that is going to lead us right back to the surprising truth about what's in your gas tank.
All right, first things first, what in the world is energy economics?
It sounds kind of dry, I know, but think of it like this. It's a special set of X-ray glasses. It lets us see right through the walls of the power plant, past the gas pump, and understand this incredibly complex web of decisions, trade-offs, and systems that bring power into our lives. It's the how and the why behind every single watt we use.
And at its very heart, just like pretty much all economics, it boils down to one single fundamental problem: scarcity. We live on a planet with a limited, finite amount of energy resources, but our desire for power? Yeah, that's pretty much infinite. So energy economics is really the study of that constant, epic tug of war.
Okay, so to really analyze a system this massive, we can't just look at it as one big blob of energy. We need ways to categorize it, to put things into boxes. Economists use a few key frameworks that really help us see the bigger picture.
So the first big distinction is between primary and secondary energy. Primary energy is the raw stuff, what we pull straight from nature. Think crude oil, sunlight, or wind. But here's the thing, we rarely use energy in that raw form, right? We have to transform it into something useful, and that's secondary energy, the gasoline that goes in your car, the electricity that powers your home. And that transformation step, it's absolutely crucial, and as we'll see, it's often where a lot of energy gets lost.
Now, next up is a big one you've definitely heard of: renewable versus non-renewable. But the key economic difference here is whether we're drawing from a finite stock, like a giant but limited underground tank of oil, or if we're tapping into a constant flow, like sunlight that just keeps showing up every day. One of them can eventually run out, and the other one won't. And that one simple fact changes, well, it changes everything.
And here's the full framework all in one place. Besides the ones we've just talked about, economists also distinguish between commercial energy, the stuff you buy and sell in a market, like natural gas, and non-commercial, which is more like gathering firewood for your own campfire. And last, there's conventional energy, which uses old, reliable tech like a coal plant, versus non-conventional, which uses new and novel technologies like tidal power. Each of these classifications gives us a totally different lens to look through.
Now, these classifications are so important because the questions we ask about energy are always changing. What kept economists up at night in the 1970s is way different from the challenges we're facing today. And these big shifts, they're almost always kicked off by major world events.
This timeline really tells a story, doesn't it? The massive oil shocks of the 70s forced everyone to focus on supply and finding substitutes. Then the 80s rolled around, and with it, a huge rise in environmentalism, which brought a whole new set of questions about sustainability. The 90s were all about deregulation and letting the market run things. And now in recent years, well, we've kind of come full circle, grappling once again with crazy high prices and the looming threat of scarcity.
So, how does a raw resource that's buried deep in the earth actually become the light in your room? It has to travel through this massive, incredibly complex, and, for most of us, completely invisible supply chain.
And this chart, wow, this really puts the sheer scale of the challenge into perspective. A whopping 80% of our primary energy comes from fossil fuels. That's just mind-boggling. It means we've built this colossal global machine that is dedicated to one thing: pulling these resources from the ground, refining them, and then shipping them to every single corner of the planet.
We can actually break that whole massive journey down into 3 key stages. It all starts with supply. That's finding and extracting the raw energy. Then comes the transformation stage, converting it into a form we can actually use, like refining oil into gasoline. And the final stage is consumption. That's the moment you flip a switch or turn the key in your car.
All right, with all these concepts in our toolkit, we are finally ready.
It's time to solve that puzzle from the beginning. Let's trace the incredible, hidden journey of the fuel that gets your car from point A to point B. So we start here, at the very end of the line. To travel 10 kilometers, your car's engine needs to burn exactly 1 liter of gasoline. That's what goes into the tank. Simple enough, right? But believe me, that is just the tip of the iceberg.
But let's rewind a bit. That 1 liter in your tank didn't just magically appear there. To account for tiny leaks during transport and all the energy the refinery itself uses, about 1.1 liters of gasoline had to be produced in the first place. So we're already losing energy before it even gets to the gas station.
Okay, now hold on, because here comes the first big leap. A refinery doesn't just make gasoline. It takes in crude oil and makes a whole bunch of different products. And if gasoline is only about, say, 30% of what it makes, well, to get our 1.1 liters of gas, that refinery needed to process almost 3.7 liters of crude oil. All of a sudden, our number has more than tripled.
And here it is, the most mind-blowing part of this whole journey. We can't just suck all the oil out of a reservoir underground. Not even close. With a typical recovery rate of just 20%, to get those 3.7 liters to the refinery, oil companies had to find and tap into a reservoir that held over 18 liters of crude oil. Just let that sink in for a second. From 1 single liter in your car, all the way back to over 18 liters of oil still in the earth. It's incredible.
This is the absolute essence of energy economics. It's exactly what this quote gets at. It is all about efficiency, those tiny, seemingly insignificant losses at every single step of that long chain. From the oil field to the refinery to the truck to your car, they all add up, creating this huge multiplier effect on the original resource.
So, we'll leave you with this question. We've just uncovered the long, hidden journey behind a single liter of fuel in your car. Now, knowing that a similar and just as complex, invisible chain exists every single time you flip on a light switch, how does that change the way you think about the energy you use every day?